Let's see an example where it says a car is moving in north direction at 10 meters per second, takes turn toward east and maintains the same speed, and we are required to find the change in velocity of car. Here, if we just have a look on the situation, initially it is saying the car is moving in north direction. Say we consider this is the initial velocity of car V1, which is moving in north direction, and the magnitude of V1 is 10 meters per second. Now it takes turn toward east. The car takes a turn toward east. So the velocity vectors becomes V2. And is saying that it maintains the same speed. Then the magnitude of the velocity vector V2 is also 10 meters per second. Vectors are different because the direction is changed. Now it is asking the change in velocity of car. Here if we consider east along x direction and north along y direction, this V1 vector can be written as 10 is the magnitude angle 90 degree meters per second, and V2 vector can be written as 10 angle 0 degree meters per second. This is the mathematical representation of the two velocities. If we find out the change in velocity delta V vector can be written as V2 vector minus V1 vector, that is final velocity minus initial velocity. If we just draw the vector triangle, this final velocity V2 is in this direction. Minus V1 is the direction which is opposite to this V1. This is the vector which is minus V1 vector having same magnitude but opposite in direction. So we just add minus V1 vector in this V2 vector. So from the starting of first vector to the end of this vector, this will be the vector which represent the change in velocity. You can see in which direction it will exist. This will be the direction which is southeast. And as the length of this vector and this vector both are equal to 10, the magnitude of this delta V can be simply written as 10 root 2 meters per second, which is a change in velocity in southeast direction. This is the answer to our question, which we can very easily evaluate by using the vector addition, or you can also call it subtraction of vectors, and by drawing the vector triangle. Let's see one more example which says if 0.5 I cap plus 0.8 j cap plus c k cap is a unit vector, then we are required to find the value of this constant c. This is quite a simple question where you can simply state in this particular situation, this given vector is a unit vector. That means magnitude should be equals to 1. So we can say magnitude of the given vector is, this we can write root of 0.5 square plus 0.8 square plus c square is equals to 1. So here we'll get the value of c square is equals to 1 minus 0.25 minus 0.64. That is c square is equals to 0.11. This implies the value of c will get root 11 by 10. This is the answer to this question. We can directly evaluate it. As we know, the magnitude of unit vector is 1. Now we'll see one more example where it is given that if for two vectors L vector and M vector, we are given with the magnitude of vector L plus M is equals to magnitude of L, and the same is equal to magnitude of M. And we are required to find the angle between L vector and M vector. Here we just directly use the results of parallelogram rule. Let the magnitude of L vector and M vector is, say this magnitude is L, and obviously the resultant will also have the magnitude L. Now in this situation we just use the relation of resultant, which is given as root of L square plus M square plus 2Lm cos theta, where theta is the angle between L vector and M vector. So here if we replace M by L, as both are having the same magnitude, we can say as magnitude of L vector is magnitude of M vector, say it is equals to L. So here we can use R is equals to L square plus 2L square cos theta. Here we take this L common out. Under the root we are having 2 into 1 plus cos theta. And I think all of you know the half angle identity, that is 1 plus cos theta can be written as 2 cos square theta by 2. Here if we use the result, we will get R is equals to 2L cos theta by 2. Now in this situation, this resultant is also given as L, as mod of L vector plus M vector is equals to mod of L vector. This is equals to say L. So here we can put the value of R as L. It is L is equals to 2L cos of theta by 2. Here L gets cancelled out and we get cos theta by 2 is equals to 1 by 2, which implies theta by 2 is equals to 60 degree, or we can write theta is equals to 120 degree, which is the answer. So 120 degree is the angle between L vector and M vector if the resultant is having the same magnitude as that of L and M.